Good afternoon, everybody. So, it has been a long day, isn't it? Yeah. So, just for some of your background, so basically, Yuqiang Li, who is the first author of this presentation, is supposed to present here, but he suffered from a visa issue. And I was a PhD student following Simon Dixon quite a few years ago. So, just that's sort of the reason why I come to DMRN. Great. So today I'm going to talk about metric learner, a two-stage differentiable discriminator network for symbolic music. So the idea comes from a data challenge we organized 2 years ago. So basically, the rough idea is we want to check or investigate whether algorithms is able to distinguish generated music and the human written music. So we basically got 6,000 fake samples of generated music by a machine, and then combine them with some of the human composed music melodies, and then ask the machine to identify whether the melody is written by machine or human. And the challenge actually runs somehow quite well. We have quite a few submissions, and it seems that the majority of the team could somehow identify the human right melodies among the the computer generated one. Sorry for that. So we basically published our results in the Izmir of 2020. Then we got an idea that Then we got another idea. Okay. So assume we get a Xi'an adversarial network. And we got generator and discriminator. Right? And one small problem with the Xi'an structure is that if we optimize the generator loss function to 0, then we got a small problem actually. The self-regressed loss function does not guarantee reduce the loss function, the value of loss function to 0 would basically generate better music or better melody. Then we come up with an idea that can we do something to make sure that once a particular loss function reduced to value of 0, then that sort of guarantee we would have sort of better melody generated. So we propose a structure named metric learner, and we hope by optimizing that particular loss function of the metric learner, we're able to produce better music. Okay, but we're not quite there yet. So this presentation basically just gives the very initial results of the metric learner thing. So the idea would be we got some symbolic music coming, and then we got a metric learner module, and then we get a set of objective evaluation matrices that related to the melody or to the music or symbolic music input. So we here select, say, 8 metrics. So 4 of them is pitch related, and another 4 of them is timing related. We got pitch mean, pitch standard deviation, pitch class entropy, and scale consistency. We got down bit rate, empty bit rate, group consistency, duration, and duration entropy. So that's basically the majority of the matrices. So essentially speaking, we are doing a regression task. So for the evaluation, right, a simple thing is we could do is to use the median absolute error to test that to test the differences between the predictions and the ground truth. So the idea is we're training this particular thing on Wikifornia first, and then use Nottingham dataset as an external validation dataset. So the most straightforward way come to our minds is to get a deep neural network, which is quite simple and straightforward. We just input the melodies and see how fully connected networks will do its own magic, hopefully. And the result seems actually somehow not very bad, right? Then we propose a further two-stage strategy. We basically to use some mathematical related methods to get the pitch distribution, duration distribution, onset distribution, and position distribution first. And then we test the sets of metrics. So we build a much smaller neural network to predict the metrics we selected. So the particular model has only less than 1,000 parameters. So basically, what we need for the non-parameterized distribution model, we basically predict the embedded vector based on its distance from our embeddings. We turn the prediction results into a nearly one-hot distribution for each time step, and then we take the average distribution among all these steps. So basically, subject, sum, and normalization at mean. So that's sort of like the story. And if we compare the resulted two-stage model with the deep neural network directly, we find that actually the majority of the metric prediction has improved compared with the DNN thing. And then if we turn to an external data set with Yuqiang, it is basically the same story repeats. So it's fairly a typical story, actually, where we know that if we introduce some prior knowledge into some particular regression task, usually the neural network is supposed to be much more efficient compared with we treat them as a black box and try our best luck. So by comparing these two particular models, we notice that the deep neural network, basically the metric learner based on deep neural network, got about 1 million parameters, and it takes 30 minutes to train the model, and it's basically a more like black box one. And the two-stage metric learner somehow got less than 900 parameters, and it takes 2 minutes to train them. And then the white box, sort of white box, I am not going to put it as like white box, but semi-black box. And then the parameter, the settings in the model is mostly linear. So the future works of this particular work is we tend to firstly introduce this metric learner to generative adversarial network structures to see whether this particular model would help to improve or say to correlate the value of loss function and the performance of music generation. Hopefully we will bring some better results next time. And then we also think about we need to extend this beyond the generative adversarial network framework. Quite obvious, because if asked the major types of music generation networks, usually people say we have currently mostly transformer-based sequence-to-sequence, we've got Xi'an, and we also got variational autoencoders. So that particularly saying that we are proposing a few more scenario of application, I would say, for using this particular metric learner. So this is a very typical variational autoencoder thing. So we are thinking about, can we actually building a decoder, so respectively a decoder that decodes the matrix we proposed, or say the feature vector we proposed, which forms a codec structure between the original decoder in VAE with a modified one. Similarly, for sequence to sequence, which sort of introduce encoder and for the particular sequence, and then decode them to again, this is a self-regression model, so that means that a value of 0 for loss function necessarily introduce a good performance of music generation. So again, we introduced a decoder for the modified sequence-to-sequence structure. And so hopefully that the particular sequence status would be decoded in a much better way, such that the loss function for the modified metric learner would basically improve this particular music generation system. So basically, yeah, the music feature, the conclusion currently we have is the music feature distribution are crucial in task of learning objective evaluation as music. And also we said that the semantic, or say the meaning of music sense of knowledge basically would improve the deep learning things and the neural network related learning process. So basically our emails are listed here. So the middle one is me, and George Fazekas from CIFR-DM also participated this work. And Yuqiang was my student last year for his final year project. And if allowed, I would like to make an advertisement for him. Is basically he's seeking PhD position somewhere. So if anyone is interested in talking with him, do feel free to drop him an email. So I guess I'll try to keep things short. So maybe we could give our audience some time to ask further questions. Thank you.